Okay, we've gone through the hypothesis testing with the z-statistic. We found that was statistically significant. Now, one of the other things that we do now within statistics is try to look at the effect size, the total effect of the study, of the magnitude of it. And effect size comes into play because if we have studies with really large sample sizes, it becomes quite easy for us to be able to find statistically significant differences. You can think of that as the analogy of a really super powerful microscope. You can find very small chemical residue, let's say on a grape or something, but that doesn't, just because you can find that because it's an intensely powerful microscope, doesn't necessarily mean that that is significant to our health. I know I've got some friends who might disagree with me on that, but I think I'm hoping that analogy stays for you. So there's times where we can find a statistically significant difference, but it might not necessarily be meaningful. All it means is that it's a difference that we wouldn't have expected to have seen just by chance. So how do we go about calculating the effect size? The effect size is actually quite easy to calculate, and so what we're going to use is what's called Cohen's d to calculate the effect size. And all that is we're going to look at the mean difference just like we did up here in the numerator. So it will be the sample mean minus the population mean, and then it's going to be divided by that population standard deviation that we have here. So really easy math. This works out even better than what we did up here, and that was actually not too bad a math. So we'd have 44 minus 40 divided by our standard deviation, which is 10, which would give us 4 over 10, which would give us 0.40 for an effect size. So what does that mean for an effect size? If we look here, and you've got a definition here, so it's helping us to get the absolute magnitude of the treatment effect, independent of sample size. And so we look here at whether or not this is a small effect, medium effect, a large effect. And so this isn't highly precise for how it is that we go about this for effect size. So when we looked at this, our difference or our effect size, 0.40 would be somewhere in between a small and a medium effect of what we'd see. The other way to think of an effect size, since we were talking about standard deviations, is an effect size of 0.5 means that one group scored a half a standard deviation higher than the other group did, or in this case, the sample group would have scored a half a standard deviation higher than the population. So if we had an effect size of 1.0, which would be a very large effect, that would mean the sample group scored a whole standard deviation higher than the other group, which really indicates, wow, we've got a big difference here. The treatment had a very big effect.